Good morning, class. Today we are going to continue with some examples on measures of central tendencies and how do we determine the mode, how do we determine the median, and how do we determine the mean. As we discussed in our previous classes about measures of central tendencies, where we discussed as a value that has been condensed to represent the entire set of observations that you've been collecting from the field. So let's see how we handle data in order to find the mean, the mode, and the median. These three measures represent the same thing. You don't have to use all the three in one data set. You can just use one or two depending on the type of variable you are dealing with, depending on the nature of data that you are dealing with. Okay, let's continue. This was an example that we had in class, and it represented ungrouped data. So how do we handle data, raw data from the field? Before you group it, before you tabulate it, how would you look at such data? However, this kind of measures can only be used if you have small data sets. So the examples we have before us, the marks obtained in 10 class tests, as you can see. And how do we find the mean? We find the mean. Now remember, we also learned about statistics and parameters. Now, assuming that this data was collected on sample basis, it means that it will be denoted by X bar. And if it was collected on population basis, then we will denote it by mu. So by mere saying X bar, it simply means that the data was collected on sample basis. So X bar is equal to some sum of X divided by N. So sum of X means that we are going to add all the observations obtained in the 10 class tests, and then we divide by the number of observations, or you can say we divide by the sample size. So N represents the sample size. So we added all the observations and then divided by the sample size, and the mean was given as 15.4, which can be interpreted that on average a student can score 15.4 in this particular test that was given to that class. Then how do we find the mode? Mode of ungrouped data, or mode for simple data, is simple. You just have to look out for a number that appears many times. You look for a number that appears most often, and that is the mode. If you have two numbers that appears almost the same time, that is bimodal. If there are three, that is trimodal. If there are more than that, that is multimodal. However, in this particular example of ours, we can only see one model. As you can see, 20 has been repeated twice, and yet the other observations are appearing once in your data set. So that gives us our model, or our mode, as 20. Then median. Median for ungrouped data, or median for simple data, we have to rearrange the data set or the observations in ascending order. In ascending order, I mean from the smallest to the biggest. As we arrange from 8 to 25, and then we cancel and we see the numbers that remain in the middle. Now, assuming that we had an odd number, then it would be very simple. If the sample size was an odd number, in other words, if we had like 3, 5, 7, 9, then we would have only one figure remaining in the middle. So it would have been easier for us. But since it's an even number, the sample size is an even number, we are remaining with two figures in the middle. So we find their mean, and then that gives us what we call the median for simple or ungrouped data. So assignment 2 was also illustrating different examples, or how do we handle data that has been grouped, or you will call it the frequency, grouped frequency. How do we handle grouped frequency? So for grouped frequency, it is the other way around, that you have to first classify your data, as we learned. in our previous class. You classify your data according to attributes or according to class intervals. Now, if our data was qualitative in nature, then we would have classified it according to attributes. But since our data is quantitative in nature, it has been numerically collected. So it is numerical in nature, it is figure. So we cannot choose attributes, but rather we are going to use class intervals in organizing this kind of data. Given the example, we have using a class interval 10, construct a frequency distribution table. So when we are constructing a frequency distribution table, still as we discussed earlier on, you can use what we call inclusive grouping or exclusive grouping. When do we use exclusive and when do we use inclusive grouping? Then two, it requires the question requires us to plot a histogram, a less than type ogive, and a frequency polygon. We discussed this in our previous lecture. How do we plot these graphs? What do we put on the x-axis and what do we put on y-axis? And then later on, which graphs do we use to estimate the mode and the median? Graphically estimate the mode and the median. For these two, mode and median can be estimated graphically. When we're estimating the mode, we use what we call a histogram, and then when we're estimating the median, we use what we call the ogive. Mean cannot be estimated graphically. It's the only measure of central tendency that we can't estimate graphically. However, these two can be estimated graphically using the histogram and an ogive. So from the above data, we are required to compute the arithmetic mean, the median, and the mode. So given the data above on ages of customers of Centenary Bank that were collected in February 2020, you will find that we had to organize our frequency distribution table in this kind of format. As you can see, we have 1, 2, 3, 4, 5, 6, 7 columns. The first column is representing class intervals. As I had told you earlier on, that when we are classifying a data, when we are organizing a data, we can organize it using class intervals or attributes. And I said attributes can only work if you have if your data is qualitative in nature, and this data we collected is numerical. And specifically, I'm taking age as a discrete variable. Remember, we also said that quantitative data can be discrete, but it can also be continuous in nature. Just to remind you, what is discrete data and what is continuous data? Discrete data is data that has been taken by counting. You count and then you record a figure. You don't expect to have fractions and decimals with this kind of data. And yet, with continuous data, is data that we record by measuring. Now, when you are measuring, you may expect to have fractions and points at the end of the day. So I'm taking this example of ages collected on customers of Centenary Bank. So my variable age has been represented as a discrete variable. So how do we classify a discrete variable? Discrete variables are classified using what we call exclusive grouping. Now, exclusive grouping, this is where the lower and the upper class limit is excluded from that class and taken to the next class. We exclude it from the class and then we take the next class. What do I mean? If I find observation 20 among my observations, I don't include it in that particular class. I rather take it to the next class. So that is what we call exclusive grouping. And inclusive grouping, this is where the lower class limit and the upper class limits have been included in the same class. Okay. So the tally column, we all discussed how we do the tallies. So I guess by this time we know how to make tallies. So from tallies, we get what we call frequencies. So the frequencies are gotten from counting the tallies. And then the cumulative frequencies, we also learned how to get cumulative frequencies by adding up the frequencies. And then x stroke m, I said it can be x, it can be m. It depends on what you want to represent midpoints with. So in this particular example of mine, I have used x stroke m, but you can choose to use one of the two letters, or you can choose any letter and then define it. It doesn't stop you from using any letter, but you can use a letter and then later on define it. So this letter x stroke m represents the midpoints, which means the observations have been condensed into midpoints. And how do we get midpoints? We add the lower class limit and the upper class limit, and then divide by 2 for each of the classes, and that gives us what we call midpoints. Then the frequent fx is frequency times midpoints. So the product of frequency and midpoints for each classes is computed, and that gives us this column of fx. Then CB is class boundaries. As I had told you in our previous classes, the class boundaries can be of upper and of lower. So we have what we call the lower class boundaries and the upper class boundaries. So, but when do we use class boundaries? Class boundaries are normally applicable if your data is continuous in nature. Remember, in most cases when you're taking measurements, take an example, you're measuring the length, you're recording length, height, weight of something, temperature, you will find that in one way or the other, you may have committed errors somehow, somewhere. So this can be catered for by use of class boundaries. So normally class boundaries are included on the table if the data that you collected was taken by measuring. If the data you collected was taken by measuring, so you had some fractions, you had some points in that kind of data, so we represent that on a class boundary. So that class boundary column, I didn't complete it because in this particular data set of ours, we took age to be discrete. Now age can be discrete, can be continuous, depending on the purpose of the study that you are carrying. If it's medical, then you'll take age to be continuous in nature. But most of the data that we have collected, probably census data, or even business data, social work data, you don't have to take age to be a continuous variable. Age is normally taken as a discrete variable. So you're either 21 or 22, you're either 50 or 45, but you can't be 22.5 years. So we are taking age in this form to be a discrete variable. So after you have completed this table, you can find the total of the fx, because it normally helps you when you're computing the mean of the given data set. Also, you find the total of the frequency column, and that's the sum of frequency given as 50, and then the sum of the product of frequency times frequency and midpoints is given as 1440. So this was explaining how do we get midpoints. We get them by adding lower class limit plus the upper class limit and divide by 2. Mean for grouped data. How do we obtain mean for grouped data? Mean for grouped data, in this case, it was a sample of ages. It wasn't data collected on population basis. That's why you are seeing X bar. Majority of researches or studies, you will find that they are done on sample basis. Why? Because of financial constraints and time constraints. You may not have all the money, you may not have all the time to conduct a study on a population. So wherever you see X bar, it is a statistic that represents sample mean. So sample mean in this case is going to be given by the sum of the product of frequency and midpoints divided by the sum of frequencies. Then after dividing, we got 28.8 as our mean. So on average, a customer, a Centenary Bank customer was age 28, or you can say 29 and rounding off. 29 years old. So when they were taking data, those were the people who opened up accounts in February. So on average, a customer was 29 years old. So given the data that we collected, this is trying to represent the population of Centenary Bank customers that opened up accounts in February 2020. So we are saying that on average, a customer then was 28 years or 29 years old. Mode. How do we find the mode of group data? How do we find the mode of group frequency? So mode has very many formulas. You will find that all of them will lead you to the same answer. So in this particular example, I used only one method of calculating the mode. And how do we calculate the mode? L1 plus D1 divided by D1 plus D2 in brackets multiplied by X by I. What do these initials represent? L1 represents the lower class limit of the model class. Now you can use lower class limit or lower class boundary depending on the nature of data. If the data is discrete, then we shall use lower class limit. If the data was continuous in nature, then we would use the lower class boundary of the model class. Or maybe another question that would rise, how do you determine the model class? The model class is determined from the frequency column. You look out for the highest number among your frequencies, and that is the one, and that is the number that gives you the model class. So D1 is the difference between the frequency of the model class and the frequency before the model class. And then D2 is the difference between the frequency of the model class and frequency after the model class. And then I is the class size. How do we get that class size? We subtract the upper class limit minus the lower class limit, and that gives us the class size, which is represented by I. So 10 plus 21 divided by 21 plus 29, meaning 21 is our D1 and 9 is our D2, 10 is the lower class limit, and then 10 is the class size. And then it gave us our answer as 70. Median. How do we determine median of group data? Median of grouped frequency is determined by first calculating the cumulative frequencies, which we have already seen in our table, in our cumulative frequency table. So how do we use the median? How do we calculate the median? We calculate the median by having L, it's supposed to be L1, still is the lower class limit of the median class, or it can be the lower class boundary of the median class, still depending on the nature of data that you collected. So n divided by 2 is the total, you can say the total or the size of the population or the size of the sample size divided by 2, and then you subtract cumulative frequency before the median class and then divide by the frequency of the median class within the median class, and then you multiply that by the class size of the median class. Now let's continue. How do we get the median class? The median class is normally gotten by looking through your cumulative frequency column, and then you find a number that you got after dividing n by 2. So in this case, we had our sample size as 50. So when we divided 50 by 2, we got 25. So when we got 25, we had to go in our cumulative frequency column and look for where 25 could really fall. So we found out that 25 could fall in 21, within 21. So that's how we got the cumulative frequency before. that's how we got the cumulative frequency. That's how we use the cumulative frequency, to find the median class. So the cumulative frequency before, that is CFB, is that value that is before the median class. So assuming we got the median class, and when we are looking for cumulative frequency before, we go back to our table and look for that value that is before our median class. That's what we put as 21. So it's 25 minus 21, and then divide by 12, and then multiply by the class size, which we say the class size is gotten by subtracting the upper class limit minus the lower class limit, and then we got it as 23.3. So in our previous lecture, we had to ask ourselves, how do I determine which measure of central tendency to apply to my data set? First look at the nature of the variables you're looking at. First look at the distribution of your data set. Those will guide you on which right measure of central tendency that you can apply to an analysis of your data. Thank you.